Using the IVT, explain why f of x equals 4 over x minus 2 does not have a real zero in the interval 1, 3, even though f of 1 is negative, less than 0, and f of 3 is greater than 0. Right, so it'd be good to remember what the IVT says. So it says, suppose a function f is continuous on a closed interval a, b. If k is any value between f of a and f of b, so in this case we've been told that f of a is negative, where a was 1, and f of b, where b is 3, is positive. Right, so if k is any value between that negative value and the positive value, then there exists a c in that interval, closed interval, such that f of c equals k, where k is between. So we're saying k is 0, as in, so you've got one negative number, a positive number. The intermediate value would say, if it could be used, it would say that there was a 0. The problem is the very first sentence. Is f continuous on this interval? So this is a reciprocal function, and you know that reciprocal functions have discontinuities. So actually, I would sort of try and I would just sketch it normally, but given that it's a sort of tricky, it's got a tricky interval, and to calculate the paper, I'm just going to have a look. So go to the graph. We know that there's a discontinuity at x equals 2, because if x was 2, you'd be dividing 4 by 0, and that's when the function is undefined. Let's have a look at the rest of it, and we'll be able to restrict the window, which is quite nice. So 4 over x minus 2. Like that. Draw it, and then we can see a discontinuity, but we're not looking at the right bit. So we want to define this closed interval, which is from 1 to 3. So x min is 1, and x max is 3. Y min and max, I'll probably stretch those out a bit, so let's go say minus 10 and 10. And have a look. If it doesn't look right, we'll come back and change it, but hopefully it'll be enough to tell us what's going on. So if you draw that, well, you can see you've got something over here, and you've got something else over here. We don't get anywhere near the asymptote. I could probably go up a bit and I might see more of the asymptote, so maybe if we stretch it out a bit more. Let's go say minus 20 and up to 20 and see if we can see a bit more. There we go, we're starting to sort of get closer to the asymptote, but basically the x-axis is in here somewhere. That's the x-axis. The y-axis we can't see, it's over there. We have here, this is when x equals 3, and here is when x equals 1. So the y-axis would be somewhere over here, but it wasn't part of our interval, so that's fine. This is f of x. So the first thing to note is that the intermediate value theorem cannot be applied when the interval that you're trying to apply it on has a discontinuity in it. You can see here, we know we've got a discontinuity when x equals 2, and it's actually an essential discontinuity, not that that really matters in this context, but we have an essential discontinuity when x equals 2, so we can't apply the intermediate value theorem. So that's telling us why we can't apply it. It isn't necessarily enough to tell us why there's no 0. So I suppose there could have been a 0 this side of the discontinuity or this side, in which case you might be able to apply the intermediate value theorem over by adjusting the interval that you're applying it over. But really, all this discontinuity is telling you is that you cannot apply the intermediate value theorem. And then if we actually look at the graph, you can see that there is no 0, but that's not really the intermediate value theorem telling you that. So we can see f of x has a discontinuity discontinuity, and it's essential at x equals 2. And because 2 is within this interval, IVT cannot be applied. Okay, and then we can see, looking at the graph, there is clearly no 0. Looking at the graph, there's no 0 on this interval.